Hello and welcome. Today we'll be doing Leetcode 349, and this is marked as an easy problem, but in my opinion, this can become a little bit challenging. It really touches on your data structure and algorithms like principles and foundation. So with that being said, let's go ahead and FYI, this problem can be solved in two ways. One way is not necessarily better, but it's good to be aware that those both two exist. And then I'm gonna have a recommendation. Once you complete this, I highly recommend that you do. I think it was like sorting two linked lists. I'll drop the number in the description. I forgot on the top of my head, so I apologize. But with that being said, let's go ahead and read the problem. So, given two integer arrays, nums of 1 and nums of 2, return an array of their intersection. So, repeating or common values from each side. Like, what are they sharing? Each element in the result must be unique, and you may return the result in any order. So order is not a big deal in the return, but they do need to be unique. So with that being said, let's just go ahead and jump right into the example. So we have nums of 1 that has 1, 2, 2, and 1, and you got nums of 2 that has 2 and 2. And right off the bat, the intersection, the common value between these two arrays are 2, and we would need to return that instead for our algorithm to be successful. So for example 2, you got nums of 1, you got nums of 2, and 4, 9, 5 is the nums of 1, nums of 2 is 9, 4, 9, 8, 4, and the common values are 9 and 4. So that's what's going to return right here. And as they say as well, 4 and 9 could have been acceptable as well. So the first approach that came to my mind is using a hash set. So a hash set just is a data structure that stores the array in its value and its index as well. And what's nice about it, you can use it as a way to remove duplicates, to get rid of duplicates by a simple check. So that being said, first, let's just declare that a variable for, we have to tell one of the input list to be a hash set. We turn it into a set, and we pick one or their nums of 1 or 2, so we can see like, say, hey, so like the scene array is set nums 1. So this has turned that nums1 input array to a hash set, and it has all the common values that we need or that we're going to be checking in our algorithm. So, and then you have the result array, because they need an array. So we're going to iterate through the other loop. So for n in nums of 2, if n in scene array, so there's a commonality here. I'm going to change the colors. Here is the intersection. Check. So if n is seen and n not in result, so we have seen this value and it is unique. So this other check that we're doing right here, so with and, is unique checker. We would like to append that value into the array. And we keep going through this algorithm, and we would like to return, because the way this is going to store is technically not, no, this should technically work. If I'm wrong, I'll bring it up in the Leetcode. But in the meantime, I'm just going to return result. But I have a feeling you might need to return list for Python for result. But quote me on that. But that being said, this is a very valid approach to the algorithm right here. So the time complexity of this guy is O of n plus m, because n would be nums of 1. So I'm going to take a shortcut here to say this is n1 and this is n2, because we have to iterate through both technically. And the space complexity is O of the minimum, I think, between well, no, this is not, because we're using a hash set for our algorithm, so this would be O of n. Now, your interviewer might like this and move on to a different question, or if they are a little bit picky, they can tell you, hey, like, could you come up with an algorithm that can turn this space complexity into O of 1 instead? And there is a way. So let's go ahead and jump to the other algorithm over here. So let's go ahead and nums of 1. I'm going to just draw it as empty. You got nums of 2. I'm going to draw them empty. So this other approach that would satisfy that requirement would be a two-pointer approach. A two-pointer where you have 2 pointers. One pointer will be pointing here, so P1 at nums of 1, and you got P2 that points at nums of 2. But before we even get started, we need to first sort the array. Sorting array will eliminate a lot of the concerns we might have. It makes us to transition between and increment through the arrays a lot better, because we guarantee that, hey, we haven't met our base condition that the pointers equal each other, but we want to at least get close to each other. So sorting them, so you got 1, 1, 2, and 2, and you got here 2 and 2. So first, like I said, sort input array, and then second, initialize the pointers and the result array, and then 3, we get that big while loop, and then 4, you have the if statement checks, and then 5, you just return the result. So with that being said, I'm going to go ahead and start kind of writing up the code algorithm here. So as we said, we're going to do nums of 1, sort, nums of 2, sort, and you got left and then right pointer. Oh, sorry. You can use that. I just want to be more better representation of the algorithm. So I'm going to say P1, you got P2, both starting at 0. And then we're going to get started with the algorithm here. So I'm going to move some of this stuff. Let's move it down here. Cool. So while P1 is less than the length of nums 1 and P2 less than, that was horrible, less than length of nums 2, make sure we're in bound. We have not, exited out of these. So I'm going to just get rid of this guy. Perfect. We're going to check first if nums of 1, P1 equal to nums at 2, P2. And so at this point we have found a match. And if nums either 1 or 2 here would satisfy the condition as long as they are consistent, nums of P1 not in result. So this is a unique checker. We would like to append this result this value into our array. Now, else if we run into a situation where nums of 1, p1 less than nums of 2, p2, we would like to tell the p1 pointer, oh, sorry, before I do that, you see, this is why it's kind of actually good to write this stuff down. You get to pick up, let me just come down here. So this is a condition where we have found our match. We want to increment our 1. Oh, let me do this separately. Can you please go away? Oh my god. Just going to bring the eraser. That's it. There you go. You're out of here. P1 and then P2 plus 1. We're going to increment them by 1. And then, but if, again, we go back to the else if condition, if the P1 is values less than the P2, we're going to tell the P1 to increment down the array, because again, this is a sorted array, and we can guarantee at least, hey, like right now we couldn't find a value that matches P2 or is less than P2, but we want to get as close as we can with the hope that we find something. So that's why we're going to tell it to increment in P1, else P1 is greater than P2 or P2 is less than P1. So we're going to tell it to P2 to increment by 1. And like the last fifth step here, I'm going to write it down here, return the result. So let's do a dry run here. So starting at 1, P1, and starting at right here, we're going to do the check as long as we're in bound. Hey, do we have a values that match? We don't, but does P1 less than P2? It is, so we're going to tell our P1 to come down here, and then we're going to iterate through the loop again. So we're going to iterate through the loop again. And we don't have a match, and hey, is this condition still valid? Is P1 still less than P2? It is. So we're going to tell P1 here to increment to another pointer, and then we're going to say, hey, do we have a match? We do. Wonderful, because 2 is equal to 2. So this guy is now 2 is equal to 2. And nums of P1 is not in res, because res right now is empty. There's nothing in there. So this condition is the unique checker is valid. Then we're going to tell it to append. So right now the result will look like this. And we're going to tell our P1 and P2 to increment because we have found our matches. Just go ahead and increment through the loop as long as we're in bound. So right now, again, we're going to run into the same case that, hey, they do equal each other. So that works. But that is not unique. We've seen these two values. We've seen 2 before. So this condition will not go through. And we're just going to go into our else condition. Else this value is less than nums of P2. It's not. They're both equal. But, hey, we have our else condition here. So we're going to tell the P2 to increment to here, and which is, it breaks this guy, and that's when the algorithm ends. So I hope this was helpful. Oh, again, and for time complexity, this guy is kind of, in the time complexity world, will look worse. So this is why this is kind of a good foundational trick, or not trick, but test towards how do you truly understand time complexity. Given that previously with the hash set we had, here I can go back here for a second, we had n plus m, but here it's actually n log n plus m log m. The reason why we have a log in here is because we have sorted the arrays initially, which is log of n, and then to iterate through the loops we have n times that. So that, and again, because they're two different arrays in a big world, it's going to be a plus to each other. But our space complexity, because we're not using a hash set, we're not using a hash map, we're not using a data structure for sake of our algorithm. So this, in the space world, you're saving a lot of memory, but you are being jeopardized in time. So you're a little bit slower, not a little bit actually, a lot slower than your n plus m. But this is a good conversational trade-off that you can have with your interviewer that I think you'll be very successful by doing so. So with that being said, I'm going to go ahead and jump into Leetcode to code up the solution. And yeah, I'll see you soon. All right, so we're back at Leetcode. We're going to code up the solution. Initially, we talked about sorting the array first, declaring the result variable or the result array, and then calling out the pointers, initializing them to 0. So let's go ahead and sort the arrays. So nums of 1 dot sort, nums of 2 sort, and you got, is that an I? Yeah, it is an I. That's funny. Result is equal to the array, and we're gonna tell our P1, P2 pointers to equal to 0. And then while P1 is length less smaller than the length of nums of 1, and P2 smaller than the length of nums of 2, nums of 2, if we run into a situation where we find a match, so nums of 1, P1, nums of 2, P2, and either nums of 1 or nums of 2 here, this is the unique checker. Jeez, I don't know why I froze there for a second. Not in result, we can go ahead and append this into our nums of 1, P1. Else if nums of 1, P1 is smaller than nums of 2, P2, then we're going to tell our P1 pointer to increment by 1, else we're going to tell our right pointer to increment by 1 because P2 is smaller than P1. So let's go ahead and return result. So let's go ahead and do a quick dry run. Initially, you want to sort the arrays. We declare an empty result variable. We have our pointers starting at 0, so starting here, and nums of 1, and then nums of 2, starting at 1. As long as we're unbound, the indexes haven't escaped the length of the integers, and we want to stop once we have exhausted all of our options. We check first, hey, does the value at P1 equal to P2? So we're going to run into a case where I think right here, once this nums of 1 is sorted, P1 does equal P2. And we can say here nums of 2 P2, but it doesn't make really a difference. Not in the result. So this is, again, the unique checker. We don't have any duplicates. We want to append the value that is an intersection and that is unique. But if we come to a case where, like we did initially, hey, like 1 is smaller than 2, so we want to tell our left pointer to increment in the array, in its own array, else P2 is smaller than P1, and we're going to tell it to P2 to increment by 1. And then once we've iterated through all the loop, or we exited out of nums2 because nums2 is shorter, then we're going to tell return the result, which would satisfy this algorithm. Again, this is a time complexity of n log n plus m log m. But that being said, let's go ahead and run this solution. It seemed like it passed our unit cases. We're going to have to submit it. Then we're going to take a look at the time complexity analyzer. We got n log n and then m log m. Memory is O of 1 because we're not using any data structures. So this will be like your efficient in terms of space, but time is a lot worse than the hash set approach that I talked about earlier. So that being said, I hope this was a helpful video for you, and best of luck with your preparations, and have a good one.